Hi guys, today we're going to work on 7.5 circle segments. So there are a few more formulas that you have to be able to know in order to solve for the different parts within a circle. So the first thing that we're going to do is we're going to factor and see if we remember factoring. I'm just going to organize this using the X or the star method, but essentially when you factor, you want to see what multiplies to b. So we have ax squared plus bx plus c. And we're going to say a times c goes on the top, b goes on the bottom. So a times c is -6, b is 1. So what multiplies to be -6 adds to be 1, and that's going to be 3 and -2. So in this case, my factors are m plus 3, m minus 2. Now, if it was actually to ask me for a solution, I would set both of those factors equal to 0, and I would solve for m. So m equals -3, m equals 2. And we did do an algebra review back in first semester, so hopefully this is relatively easy for you, but make sure that you do review those factoring concepts. So in this case, if I have a that's not equal to 1, so this was a equal to 1, I'm going to make a star when a is not equal to 1. And I'm going to put the first number, so the a value and then the variable, the a value and the variable. Same thing on the top, a times c, which is 15, b on the bottom. So what multiplies to be 15, adds to be 16, that's going to be 1 and 15. If you can reduce the fraction, so 5 and 1 don't reduce, but 15 and 5 do. So that would become 3 and 1. So that means my factors are 5n plus 1 and 1n plus 3. If you have learned a different way to factor, a lot of people do it by grouping. Basically what would have happened is we would have had 5n squared plus 1n plus 15n plus 16. So we bust that middle number. Plus 3, there we go. And then you factor out the GCF out of those factor pairs. So in this one, it's n, you're left with 5n plus 1. In this one, it's 3, you're left with 5n plus 1. So your factors are n plus 1 and 5n plus 1. So whichever way works for you, make sure you know how to factor quadratics. Not anything too complicated quadratics, just those basic trinomials. So from here, this is the first one that you're going to have to be able to determine. So for two secants, where are the angles intersecting? And we know that that is outside of the circle. So the formula that we're going to use is outside times whole equals outside times whole. So the outside of the bottom secant is c. The entire one is d plus c. A lot of people want to know or want to say that it's dc, but that's when those pieces are multiplying. If I want to find the entire piece, I add those two pieces together. The outside of the top secant is a. The whole would be b plus a. So you're taking the outside times the whole equals the outside times the whole. So for this first example, I'm going to use the red for this secant. The outside is 3. The whole is 3 plus 5. And I'm going to set that equal to the blue secant. The outside is 4. The whole is 4 plus x. If I can, I'm going to go ahead and simplify within the parentheses first. So 3 times 8 equals 4 times 4 plus x. I've got to distribute that 4, so 3 times 8 is 24, equals 16 plus 4x. Subtract 16 over on both sides, so 24 minus 16 is 8. 8 equals 4x. X equals 2. All right, and for this next one, a little bit more complicated because we're dealing with expressions here. So the green one, the blue one, the outside is 4. The whole is x minus 3 plus 4. So it's that entire length. On the bottom, the outside is 5. The whole is x minus 6 plus 5. And I'm going to simplify in the parentheses first. So 4, x doesn't change, but this would become plus 1. 5, x doesn't change, but it would become minus 1. Now you got to make sure that you distribute your values outside of the parentheses. So 4x plus 4 equals 5x minus 5. And from there, just simplifying, it's like a two-step equation. So I'm going to add 5 over on both sides. That's going to be 4x plus 9 equals 5x. Subtract 4x, 9 equals x. Okay, so that's the first formula that you're going to have to manipulate. The next one that we're going to look at is a tangent and a secant. So in this case, I've got one tangent line and one secant. And the intersection, again, is still going to be outside. But the formula that we're using this time is tangent equals outside times whole. So the tangent is the piece that doesn't intersect through the circle, and then outside times whole, just like the secant. So anytime it's a secant, you're really looking for this. So in this case, I want to ask myself, what's the tangent? For example, 3, what's the tangent? And it's going to be that 15. And then that means that this guy is the secant. So it's tangent squared, so 15 squared equals whole, or outside, which is 9 times whole, which is 9 plus x. And then I'm going to solve this, just an algebraic solving. So 15 squared is 225 equals 81 plus 9x. Subtract 81 on both sides. So 225 minus 81, 144 plus 9x divided by 9. 144 divided by 9 is 16. And frequently you do get whole numbers. So if you get a decimal, just kind of check your work to make sure that you're getting the right thing. Okay, for example 4, the x is the tangent. This entire piece right here is my secant. So tangent squared, so x squared equals outside times whole, 4 plus 12. X squared equals, and I'm going to simplify in the parentheses first just because that's how my brain works. And then 4 times 16 is 64. X squared equals 64. Take the square root, x equals 8, or it could equal negative 8. But in this case, the negative 8 wouldn't make sense because the tangent is a length of a line. So a negative wouldn't make sense, so it's going to be the 8. All right, and this is just some examples to try, so go ahead and try these two. What do you notice about these? What's the same? The same is that they have angles that intersect outside. However, this is 2 secants over here, so that's that formula. And this one is 1 tangent, 1 secant. All right, so make sure you practice these. Ask your teacher questions if you have any on these. But want to go back over the last formula that we need to know for these segments. They intersect where it's inside the circle. So this time we call it piece times piece equals piece times piece. Now these two pieces come from the same chord. So it's the same chord pieces equaling the same chord pieces. So A times B, so looking at the picture to the right, A times B, notice A and B are on the same chord, but A is the top piece and B is the bottom piece. And I'm setting that equal to C times D. So just kind of an example, a couple examples for you. A is this piece, 6 is that piece, 6 is this piece. So 6 times 6 equals, and then I've got X, which is one piece, and 9, which is one piece, so equals 9 times, it's being glitchy right now, there we go, 9 times X. Solving just like you would, 36 equals 9x divided by 9, x equals 4. All right, a little more complicated of a question. So piece times piece equals piece times piece. So 12 times x equals 6 times x plus 2. And notice that when I was multiplying by an expression, I put it in parentheses because that's going to trigger me to say I need to distribute that 6. So we have 12x equals 6x plus 12. Solving this just like you would in Algebra 1, subtracting 6 over. We have 6x equals 12 divided by 6, x equals 2. Okay? And you can plug those values back in. So just be careful, ask what the question asks. I know I'm really terrible at reading the questions, but make sure that you read, is it solving for x? Is it solving for a piece of a segment? Is it solving for the entire chord? Just make sure that you're paying attention to those directions. Okay, the last one, an archaeologist discovered a broken piece of what appeared to be a plate. She decided to take some measurements and attempt to find out how large the original plate was. So that little grayed area is the broken plate that she found. She measured the chord from AC, from edge to edge, to be 8. So the entire length here was 8. She also measured BE, which is a perpendicular distance from the edge of the plate to AC, to be 2.5. what is the diameter of the plate? So the big thing that you need to know here, which I think the directions are terrible at asking or telling us, is that this is here, BAC is a perpendicular bisector of BD. So what that means is that that AC, so if that total length is 8, that means this is 4 and this is 4. And similarly, this is going to be, if that's 2.5, okay, then this also is going to be my x. I'm trying to solve for this length. I don't know that length. So then I can go ahead and use that chord, piece times piece equals piece times piece. So 4 times 4 equals 2.5 times x. 16 equals 2.5 times x divided by 2.5. I promise you the directions will be more clear for next time, because that perpendicular bisector, not just the fact that it was perpendicular, but because it bisected, was a very important piece of information. So 16 divided by 2.5 is 6.4. So x equals 6.4. But again, this question wasn't asking me to find what x was, it was asking me to find the entire diameter. So you'll notice that BD goes through the center of the circle, therefore BD is a diameter. We have the one piece, BE, and I'm adding the piece ED. So BE measured at 2.5, ED we just calculated to be 6.4. 2.5 plus 6.4 is, of course, 8.9, which is my diameter of my original plate. And if we're looking at what the actual measurements are, it's measured in inches. All right, so those are your segment notation. Make sure that you're practicing on the worksheet provided, asking your teacher questions if you have questions.